Hi there, welcome to Service Mesh Academy for what's coming in Linkerd 2.14.
Woo!
Actually, while we give everybody a couple of minutes to join in and ask questions, I think I'll just take the slides down. The best place to ask questions or tell us where you're from or generally heckle is in the workshops channel on the Linkerd Slack. Hopefully we will see y'all there. While we're talking about things like that, there's,
Stop
you can
in and
ask.
say hi.
Yeah, you can ask in the Linkerd 2 channel if you've got general Linkerd questions, but I'm going to leave that one up right now for places to come to the workshop. We'll take a few minutes here to let everything get set up, and if you want to let us know where you're coming from, we always love to hear things like that. In the meantime, I'm Flynn, that's William, and hopefully this will go well.
Flynn, where are you coming from today?
I'm outside of Boston, Massachusetts, in the US. And you? I think you're in a place that's much hotter.
Deep in the heart of Texas. I'm in Austin, Texas.
Yeah, that would be hotter right now.
It's warm.
Yeah.
It's warm.
Yeah.
Air conditioning cures all problems.
Oh boy, I see Dan Williams says that they've just started their multi-cluster journey at Love Holidays. So, yeah, you're in the right place, Dan.
Are you sure you want to do it?
I don't know. I think it works pretty well.
Just have one giant. Why not just have one giant cluster?
Well, what do you think? What do you think? What's the worst that could happen if you have just one giant cluster?
The worst that could happen?
Yeah.
While typing in the commands, you suddenly die of a heart attack.
Uh, that I think would qualify as the worst for you, definitely. I think that the worst could happen from the perspective of the people who are trying to use things in the cluster is that the whole cluster goes down at the same time, or their data center falls.
You mean for the
Yeah.
cluster? Yeah.
Sorry, I should have specified. I know William is such a ray of sunshine. He always demonstrates excessive empathy and so much caring for everybody around him.
The worst that could happen is you have to learn too much about Kubernetes, and that takes up valuable space in your brain that you could use for more important topics.
Like almost anything. Yeah. Yeah. Welcome to the cynical side of cloud native with Glenn and William. All right, I think that we can take a couple more minutes here. It's possible that I was also just killing time waiting for my own clusters to come back up and be working again, but surely not. Surely I would never do such things.
Clusters with an S. That's your problem. Should have had
Yes,
just one big cluster.
clusters with an S. It's going to be a little different from the normal demo I run.
Yeah, so Dan, since you're just starting this journey, you're going to have an interesting choice to make, which 2.14 will present before you, which you didn't have to make before. So,
and we will be talking in great detail about this choice.
We're going to fill up your brain with all sorts of important knowledge.
Yeah. And it really is important because we're the ones who are telling you it's important. All right. I think we can go ahead and get started here.
Let's do it.
Okay. So, yes, this is what's coming in Linkerd 2.14. I am Flynn. He is William. You can find me as Flynn at buoyant.io and him as William at buoyant.io. You can find me as Flynn on the Linkerd Slack or the CNCF Slack or the Kubernetes Slack, or honestly, I feel like all the Slacks. And I guess William still likes to use TwitX, or
we just call it Twitter. We're not calling it the new name.
That's probably a good call. Yeah. So yeah, with that, a little bit about the agenda here. Like our previous what's coming in a release SMA, this is a little heavier on the slides than we normally do for Service Mesh Academy, just because there's a fair amount of stuff to cover. We're going to talk about upcoming Linkerd 2.14 features, and then we're going to do a demo of the Faces app, but the multi-cluster Faces app, which didn't exist before a couple days ago. I'm calling this a demo instead of a workshop because the code is available. It's already up on Git. You can go and take a look at it. And when you do go and take a look at it, you will find that getting K3D working properly with a multi-cluster setup the way we need it to is complex. And I would rather just demo it right now and then let y'all go and work with it on your own time afterwards. That's why I'm not calling it a demo or a workshop, but I'm calling it a demo. Basically the same idea as what we normally do, though. So with that, I believe I am going to flip it over to William for some words from our sponsors. Let's see if I can figure out how to do this.
Huh. Whoa. Wow.
There we go.
Okay. Yeah, Flynn and I are tag teaming on the slides today. Of course, he did all the work to create the slides, so I just get to talk over them.
Actually, Catherine gets credit for this slide for sure.
So
but we've never done the tag teaming thing before, so you know, everybody cross your fingers.
We've got a couple ads to get through first. I'm not supposed to call them ads; they're nice informational messages. The first is Buoyant, alongside a couple other companies, are doing a very cool free conference called Multi-Cluster Deployments at Scale. Called KubeCrash. The topic is multi-cluster. So if you like multi-cluster, this is a fun one to check out. We're going to be joining, Sivo and Fairwinds and Venafi and a whole bunch of, and Cockroach and a couple other exciting companies to present a whole series of technical talks around open source and building a stateful application across multi-cluster Kubernetes. So please register for that and check it out. Next up, of course, we've got our Linkerd forum, which I have to continually remind you to use because Slack is transient like life itself. Slack goes away and no one ever remembers that you were there, and your messages disappear into oblivion and you're forgotten forever. But on Linkerd's forum, this is, immortality. So here your messages live forever, and people can search and find them, and other people can, get the same answers. So please join us there. And then finally, of course, we've got our certification course. So if you want to get a fancy badge under your LinkedIn, you can go to learn.buoyant.io, walk through our course, also created by Flynn and myself. A lot of effort put into here. There's like online components and stuff. It should take you somewhere between 1 to 3 hours of total time to complete this, and then you are certified in service meshes, and you get a little badge for your LinkedIn.
And you can also go and register and tell us what you'd like to see in the next one of those courses as we put that together.
Yes, that's right. Yeah. Okay, one final ad, and then I promise we're getting to the good stuff, but I talked about this last time. We are releasing an evil enterprise edition of Linkerd.
I mean, wait, evil?
Well, and probably not, but it has a bunch of cool stuff above and beyond what's available in the open source, trying to do this in a very in a way that makes a lot of sense for the open source community, and no one feels like they're left behind. But if you are interested in having this conversation, the call to action is to send me a DM on the Slack, and I will tell you all about it. So that's really all that there is to say for now. A lot more noise and announcements and news coming out of that one. Oh, I thought that was the last one. We actually have one more. Our next workshop, if you want to pre-register for that, is we're going to be looking at external CAs and Vault and how to combine all of that with Linkerd. This actually is a topic that's extremely relevant to multi-cluster because, as you'll find out, one of the things you really need to do in multi-cluster land is make sure all of your clusters have the same trust anchor. And if you don't do that, then they can't talk to each other. So, minor problem. Okay. Thank you to our sponsors for those words of wisdom. And now on to the good stuff. So 2.14, Linkerd 2.14. The very first question is, when is this thing going to be out? And the answer is next week. We're just about a week away. We actually, I believe late last night, Pacific time, dropped our release candidate. So this is your chance to try 2.14 out and report bugs before it becomes an actual 2.14. We're feeling pretty good about it. We've been doing all of our usual and unusual load tests, stress tests, regression tests, analysis, and so on. So far, things are looking really good. But please, if you have a moment to try the latest Edge release, it's marked as a release candidate for 2.14, and would love your feedback sooner rather than later.
Just
So what's
just
up?
for reference, William, the demo is using that RC.
Yeah, excellent. So we will see this thing live and in action, and if it breaks horribly, then I guess that'll be
We'll
good
learn
feedback. Yeah. All right. So what is actually in 2.14? There's a couple juicy and exciting things. First is multi-cluster support for flat networks, and we're going to talk a lot about that. And Flynn's going to give a demo. And Dan Williams, this will be relevant to you for sure, and maybe hopefully relevant to other folks. That includes all sorts of other benefits and stuff. And the other big feature here is gateway API conformance, and I'm going to talk a little bit about that and some of the work that is involved in getting to that point. And of course, many bug fixes, and hopefully no bug creations. So let's dive into each and every one of these exciting features one by one. Flat network, multi-cluster. So this is multi-cluster without the gateway components. And thank you, Flynn, for putting these slides together and all these animations. Send all complaints to Flynn and all praise to me. So in 2.13 and earlier, so up until this very moment, the way that multi-cluster has worked in Linkerd has been by using these multi-cluster gateways. And the reason we started with this approach is because it is a very generic approach. It'll work in almost any situation. You need to have IP connectivity between these gateways, but that's really the only requirement. Otherwise, the clusters can be different cloud providers. They can be one on the data center, one in the cloud. They can be in different data. They can be next to each other. It doesn't matter. This works everywhere, right? It's independent of your network, of your underlying network topology, with the one requirement, again, that the gateways have to be reachable from each other. So in this world, when workload 1 wants to talk to workload 2, you need to, the application doesn't need to do anything, right? That's kind of the magic of Linkerd. As far as the application is concerned, it's talking to workload 2, and it doesn't even know that it's on a different cluster. Linkerd will transparently route that. And this actually diagram is completely wrong, Flynn, so that's a demerit for you. It does not go through the gateway on the source side. It only goes through the gateway on the destination side. So workload 1 will go through from its proxy to the destination gateway on the remote side, and then to the workload on the destination side. Also a demerit for me because I reviewed these slides and it looked beautiful and symmetric, and I didn't even realize
everybody,
how terribly
this is what happens when you
wrong
prep
it was.
slides for the CEO.
This is 100% wrong. Okay, so ignore this gateway over here. This doesn't exist, right? This one on the left, does my mouse get reflected?
Yeah. The one on the left does not exist.
Okay. So ignore.
All right, I am duly chastised and enlightened.
Now the caveat here is that, of course, with this gateway here, you add latency. So it's an extra hop, right? The gateway is nothing more than a Linkerd proxy, so it's the same proxy that you're using everywhere, but it's an additional hop in there, and like anything, it's going to add latency. And then another big caveat here is with the identity. So as far as workload 2 is concerned, the request is coming from its local gateway component. Okay, and that means that the identity is of the callers of the gateway and not of the original workload. Now, we've had a lot of discussions, and I think there is a way of
one more animation
solving this in the long run.
There's one more animation that's relevant there. That's what workload 2 is.
Yeah. Okay. Right. So from workload 2 from workload 2's perspective, that's the identity. Now, we've had a lot of discussions in Linkerd land about how to do this, and can we bundle the identity and stuff? It's possible. It gets a little complicated, and it gets dangerously close to the world of us kind of inventing security protocols and stuff like that. But I think there's a solution there. But the nice thing in 2.14 is, with a huge caveat, which I'll talk about in a minute, we can actually get rid of the gateways for the data path. So we can do communication between these two workloads without requiring going through that gateway hop. And, of course, that means all sorts of nice things happen. You get identity preserved, so you have the actual client identity. All that MTLS goodness continues to work. Everything you know and love about policy still works. You get less latency. You don't have this gateway component that you now have to monitor with as much care as you did before. So lots of advantages to doing that. But of course, it's called flat network multi-cluster because this means it only works if your clusters are running on a shared flat network, which means you now have to do something special at the layer 3, layer 4 level to make this work. So in particular, what it means is you need pods and different clusters to be able to reach each other, right? So that means the clusters need to have different CIDRs, need to be assigned IP addresses from different CIDRs, and those IP addresses need to be able to reach each other. So if you have set your network up this way, then great, you can take advantage of this. If you haven't, then you will continue using, you'll have to continue using Linkerd's original multi-cluster approach, which is fine and wonderful in every way, except for those two caveats.
And
now,
all of the
stuff that is not in these slides.
Sorry,
Go ahead.
All the major cloud providers can provide that sort of flat network for you, if I recall correctly. Do we know of any that cannot?
Right. So if you are using, if you have all your clusters in AWS or GCP or Azure, then you can do this, I don't know, VPC peering or some network thing that I don't understand. If your clusters are split across cloud providers or in a hybrid situation, or you have kind of an evolutionary lifestyle where you've aggregated clusters over time, then you may not be able to do this. But if you can, it's really nice.
Or you may need to do a little reconfiguration, or potentially more than a little reconfiguration to get into this state.
Yeah, that's right. Now, what is kind of hidden in these slides is all of the kind of beauty of Linkerd's multi-cluster approach. So, regardless of whether you're doing gateway, or gateway lists with shared flat networks, the guarantees that Linkerd gives you for multi-cluster are A, that it's going to be transparent to the application. So the application never has to care. B, that it's going to be all dynamic. So if you have a local version of a service and 7 different remote versions on different clusters, you can shift traffic around and the client doesn't know anything about it. You have full control as the operator. So you've decoupled your application topology from your cluster topology. And then guarantee C is that this is always going to happen over MTLS. And it's always going to be as secure as the world knows how to make connections. So even if you are going across the open internet, everything's secure. You have mutual TLS and cryptographic workload identities on both sides, and so on and so forth. So a lot of the work that went into 2.14 was, and actually it was a tremendous amount of work to make this happen, was not around, well, how do we do the connection from one pod to the other? Because now that the network is giving a lot of that to us for free, but it was instead, how do we do service discovery in a way that makes sense so that we can give you that guarantee of transparency to the application? And how do we do it in a way that doesn't overload the system, that doesn't overload the kube API on either side? What if you have a really large cluster and you've got all these IP addresses and they're all churning all the time? All of those difficult engineering and distributed systems concerns went into the design for 2.14. So from the user perspective, it's very simple, right? It's like you do a thing, you use a link resource just like you did before. You annotate your services just like you did before. You have a trust anchor. We'll talk maybe a little bit about that now, and then a lot about that in the next workshop that's shared across clusters. But under the scenes, there's a huge amount of effort involved in the service discovery aspect, especially of maintaining that state between clusters, right? Because Kubernetes doesn't give us a lot of great ways for maintaining state across clusters, and that's like an even more horrible, gruesome distributed systems problem than maintaining state within a cluster. Whew. Okay, anything you wanted to add to that rant/diatribe?
Two things. The minor one was that last note on the bottom about clusters. Each cluster should probably have a different identity trust domain that gets into being able to enforce authorization policies where you can know, you can do things like say, oh no, this whole cluster is blocked off. The other thing, which is larger, that I was going to say is that this whole thing with 2.14 has actually been a really excellent example of a place where the developers made their lives ridiculously harder in order for the users' lives to be easier. And speaking as somebody who put together the demo as a user, yeah, that was really nice. It really is pretty simple from a user's point of view.
Yeah, that's great. That's great to hear. And actually, I think I would amend that bottom thing about that bottom sentence. I would say you must have a different identity trust domain, unless you are doing something that is very unless you really know what you're doing. I don't see there's any reason to not have a different identity trust domain per cluster, because you can always tie them together in the policy.
Yeah.
You can always tie them together and say, I accept this from any of these
Yeah.
clusters. But unless they're distinct, you'll never be able to distinguish them in
Yeah.
policy
I said should because I agree with you. I think you should. It'll work if you don't, with some caveats around what you're able to do in policy later. So you should definitely do that. It's a good idea.
That's true. So I'm actively monitoring this workshop channel, expecting
lots of
500 questions, but I don't see anything in here. So maybe we together have explained everything that everyone wants to know.
Or they're waiting to find out if the demo crashes, and then they'll just heckle us mercilessly.
Well, they'll heckle. I will join them in heckling you mercilessly. Okay, before I get into Gateway API, any questions? I'll wait for 12 seconds. Any questions about multi-cluster for flat network?
I'm trying to think of it.
I have a question for you, Flynn, a challenge question.
Hit me.
Does the gateway component exist when you're in flat network
mode? It does, and we will talk about that during the demo.
Okay, yeah. Excellent. Great.
I'm glad he didn't ask me that 3 days ago. I might have gotten it wrong.
Well, I also had to discover that. Okay. If you think of any questions about this incredible feature that took a huge amount of effort and will change everything about your life for the better in the future, please type them into the workshop channel on the Linkerd Slack. All right, next big exciting feature. Maybe exciting is overstating it. It's exciting if you are a certain class of.
It's exciting for at least half a dozen people out there, I'm sure.
Right. If you're on the Gateway API team, it's extremely exciting. Is our kind of continual progression towards the Gateway API. And I think we have officially passed a conformance check, which is really exciting for us. So for those of you who have not been exposed to the Gateway API since Linkerd 2.12, we've basically been incrementally adopting this as a core configuration mechanism for Linkerd. And the Gateway API started out, so it's in Kubernetes today. If you have a modern Kubernetes cluster, these CRDs are sitting on your cluster already. And it started out as a replacement, effectively, or a supplement to the Ingress API. So that original Ingress API, you're probably familiar with it. Very minimalist, very hard to do. Anything non-trivial purely with that API. So you end up using kind of your Ingress controller specific APIs. Gateway API, the original goal here was, let's give you such a rich, flexible, and extensible API here that we can actually capture all the variety of configuration that we need for specifying ingress traffic. So we actually have this API that every ingress provider can conform to, and that's good for users. Turns out they did such a good job that it actually applies, largely applies to mesh traffic, not 100%, or at least not originally 100%. But in Linkerd 2.12, we started adopting it because it was really useful. We had these mechanisms for expressing things like, give me a class of HTTP traffic parameterized by, a specific HTTP route, or a specific, query param, or some combination of headers or whatever. Gateway API gave us a way to do this. And our very own Flynn has been actively involved in this very scary initiative called the Gamma Initiative, which sounds like it's creating a race of super mutants.
Thankfully, it has nothing to do with
But
gamma
it's
rays.
instead, right, yeah. Well, so it has instead, as far as I know, not been doing that, but it has instead been adapting the Gateway API to better cover the mesh use case. And I think that's kind of where we're landing, both on the Gateway API side and on the Linkerd side. Flynn, do you want to add to that? You want to take it from there? What is this Gateway API v0.8.0 mesh profile, and how does it relate to 2.14, and what's happening in
So
Gateway API 0.9?
we don't think there's going to be a 0.9, just FYI.
Straight to
1.0. So as William pointed out, the Gateway API was originally intended to be a replacement for the Ingress resource. So a lot of things about Gateway API were originally tailored very specifically to the Ingress use case. In particular, the Gateway API's concept of being conformant to Gateway API actually required you to be an Ingress controller. It was not possible to be conformant to Gateway API unless you provided an Ingress controller that obeyed specific rules. Fairly recently, the Gateway API folks defined the concept of conformance profiles, where you could say, you could define a subset of the Gateway API that was meaningful and that was portable across vendors, and say, we are conformant with this profile. And then right after that, we arranged for a profile whose name is mesh. And the point of that profile is to express the part of Gateway API that matters for service meshes, whether or not they are Ingress controllers as well. So the mesh profile is new in Gateway API 0.8.0. The current status of 0.8.0 is that an RC has been cut, and everybody is crossing their fingers for it also landing and being formally accepted in like next week or so. So as of 0.8.0, it is possible to test a service mesh to see if it is conformant with the mesh profile. And we did that with Linkerd, and it is. Yay! The nice thing about that one is that it gives you some assurance that Linkerd's implementation of the Gateway API for meshy things should in fact be compatible with other vendors' implementation of Gateway API meshy things, which should make it easier for you to move from another vendor to Linkerd. Obviously, you would never want to move from Linkerd to another vendor, so we don't have to talk about that direction at all.
Unsupported.
Yeah, I mean, yeah. So yeah, that's the state of the world there. Oh yeah, and sorry. So right after, the goal is to take Gateway API to 1.0, hopefully by KubeCon. So everybody can cross their fingers for that too.
Yeah, so I think there's a couple of ways of looking at this from the perspective of a Linkerd user. The first is, okay, here's some gobbledygook, like I don't really care, whatever, just give me the CRDs and let me configure them. And I think it's it's valid. The second is, okay, now I have to do a bunch of work in the future to migrate from service policy and SMI to Gateway API. That's annoying. Why are you guys doing that? And then the third, and hopefully, the one I would encourage is like, okay, great. This actually gives me a configuration language that is already on my cluster, so Linkerd doesn't have to introduce new CRDs, and B is starting to converge with the world of Ingress controllers as well. So in the long run, I can use the same mechanisms to configure Linkerd as I am configuring my Ingress controller. And I think that's really the goal for us, is like, that's the point we'd like to get to, is you have one thing to learn, which is this Gateway API, which is nuanced and rich and complex in many ways, but you only have to learn that, and you don't have to learn something in addition to that. That's kind of the end goal. Okay. There is a great question from Jan on the workshops channel, and it looks like you have answered that, Flynn. But for posterity, Jan is asking today, we generate service profiles from Swagger in order to get route metrics. So that's very cool. So you take your Swagger file, Linkerd has supported this for a while, describing your application's routes. You give it to Linkerd. Linkerd says, here's a service profile that you can apply as configuration that will allow us to capture per route metrics. And he's asking, can we now drop service profiles and get route metrics purely from our new HTTP routes? And the answer is?
The answer is I have to unmute first, but the answer is not quite yet, I'm sorry to say. There are still a few things where service profiles can do them and HTTP routes cannot yet do them. So yeah, the answer is not yet. It's something we're actively working on though. So hopefully sometime soon-ish, the answer will be absolutely, you can go and do that.
Yeah, I think it's plausible for us to get there in a 2.14 point release. Not guaranteed, but it's plausible. We're getting pretty close.
Yeah.
I don't want to deprecate, and I don't think we'll deprecate service profiles for a good number of releases yet. There's a lot of users out there, and I want to make sure that we have, at a minimum, a really clear upgrade path or conversion path from service profiles to the new HTTP route stuff.
Definitely.
So, yeah, for the short term, feel free to continue using service profiles. I don't think that'll change in the near future. The stuff where you're going to encounter the Gateway API the most right now, where you have to use it, is things like the authorization policies and what am I missing, Flynn? Circuit breaking?
Circuit breaking is a big one. Auth policies is a big one. Fine-grained. There's a certain amount of fine-grained, route modification stuff that you can do, actually. Actually, that's a good one that I didn't explicitly call out when I was making the Gateway API slides, but I don't think. But we do in 2.14 support a couple of the Gateway API's HTTP route filters that can do things like modify headers for requests or responses. And that's a thing that you cannot do.
Oh, yeah. No, I don't think it's circuit breaking. Yeah, so circuit breaking, I think, is
an yeah, you're right. Today. Circuit breaking is currently an annotation.
Right, it's the per request routing or the dynamic request routing. So it's the security policies, or what do we call them?
Fine-grained auth policy,
authorization policy,
dynamic request routing.
Right.
I can't believe that we both. I guess I can believe that we both got that wrong for a second there. Dynamic request routing and.
You should not trust us about anything Linkerd related.
Clearly,
clearly,
really. We should be doing these about Istio, and then then it would be okay that people couldn't trust us, right?
Yeah. Okay. So 2.14. So the one, because we are now conformant, that means we amazingly get to use the proper types, the gateway.networking.kates.io types, rather than the policy.linkerd.io types, which is kind of how we were getting around the fact that in 2.13 and earlier, we weren't actually 100% conformant. Now that we are, okay, we can use the core types. So again, we're going to continue supporting the policy.linkerd.io types for a while. If you're doing something new, use the proper types, and then I think in the long run, when we do deprecate the policy.linkerd.io types, it'll literally just be a string replacement where you switch policy.linkerd with gateway.networking.kates.
There's
at least that's the goal.
There's one important caveat for new installations to still use policy.linkerd.io, which we will talk about in the demo, but the really short version of that is if you want to use HTTP route timeouts, you must use policy.linkerd.io for right now. And like I said, we'll talk about that one.
Yeah. So this is this is a particularly fast-moving part of the world. Not only is Linkerd moving fast, but also the gateway spec itself is moving pretty fast very fast for a spec.
Ridiculously fast for a Kubernetes spec, especially.
Okay. Well, so one thing we did add as part of this.
Sorry.
Oh, this is the example, right, that you gave of timeouts. Okay. Oh, very awkward. Yeah. So we do have timeouts in HTTP routes. But again, if you're using these in service profiles today, I would stick with that, until things kind of settle. That's my. Okay, 2 types of timeouts. Are you getting into any of this in your demo, Flynn?
Just a little bit. I'm not using a backend request in the demo. Backend request timeout in the demo.
Okay, and this is all documented as part of the Gateway API docs?
This is documented. If you hit space once more. Okay, sorry, twice more. The gory details about what the request timeout means and what the backend request timeout means are all in Gateway Enhancement Protocol, GEP 1742. You can see a link to that on the bottom. GEP 2257 has the gory details of the exact syntax allowed in a timeout field. But yeah, the short version, and there is a slide about this coming up, is that if you specify a request timeout, you're talking about end to end, the whole thing. And if you specify a backend request, you're trying to specify a smaller piece of network activity.
Right. So this is a little different from what's in service profiles.
Yeah.
But
so that's the request timeout. If you've got the client workload using an HTTP route to talk to workload 1, and then workload 1 goes off and talks to workload 2 behind the scenes, timeouts.request covers that entire interaction all the way through. And the backend request only covers the part where workload 1 is talking to workload 2. In the Ingress world, and this is a case where this is a gateway API thing, not a gateway API for mesh thing. So this is one where the timeout spec has to be able to cover both of those use cases. In the Ingress world, this distinction gets to be much more important than I think it probably is for the service mesh world.
Yeah.
My suspicion is that most of y'all in the service mesh world will just use request and be done with it. But the backend request is there if you need it.
Everything's a backend from our perspective.
Exactly. That's why the distinction's a little silly is probably too strong a word. I just don't think it's a terribly relevant one for service mesh users, at least not very often.
Yeah. And then here's the work you were talking about timeouts only being in the policy.linkerd.io versions. So again, for those of you who are using service profiles today, I would recommend just continuing to use them until all of these things land in place. A lot of this is incremental progress, which is excellent, but until the warts get dewarded,
Yeah, the timeout enhancement protocol, GEP 1742, basically got all the way to the finish line, and then people realized, oh, wait a minute, we have to be more careful about the syntax that you can put into a timeout's value. And that discussion, which was a fascinatingly involved discussion with lots of people feeling very strongly about lots of things there. That took enough time that getting that into 0.8.0 kind of burned up the runway that we had. So timeouts will officially be supported in Gateway API 1.0 rather than 0.8.
There you go. It's the beauty of standards bodies. Yep. All right, we've got about 20 minutes left. Flynn, do you think that's enough time for your incredible demo? All right, in that case,
we'll find out. All right, so in theory, this is now my slide stuff. Actually, you know what? Let's switch back over here for 1 minute so I can actually talk about the architecture a little bit. All right, certainly if you saw the 2.13 what's up, you will have seen this architecture already, but we're going to go over it again. We're using the Faces app, the Faces demo, where you've got a single page web app that talks to a service in a cluster called Face. The Face workload goes and talks to a Smiley workload and a Color workload. Smiley is always supposed to return a grinning face. Color is always supposed to return green. Face sticks them together, and the GUI shows you a bunch of these all in a little grid. So if everything is going well, you're supposed to see a grid full of grinning faces and green backgrounds. We also have this smiley2 service, which returns a hard-eyed smiley, which I'm not actually using in this demo, and a color2 service, which returns the color blue. So that's the normal single cluster smiley demo that everybody hopefully knows and loves. For this particular workshop, we are splitting that up so that the workloads all live in different clusters. This diagram is a little bit wrong in that we are going to start with a color workload running in the same cluster as the face workload, but this is where we end up with everything is running in 3 separate clusters, and it all is going to work flawlessly, despite the fact that they are in totally different clusters. In theory, everybody cross your fingers for the demo gods. Oh yeah, and this actually turns out to being something of a mistake on my part. I named the cluster for the face workload face, and the other one's smiley and color. And if you are looking at this demo, especially if you're looking at this demo later and you're going, oh yeah, I'm going to follow the same sorts of things, your life will be slightly easier if you name the clusters slightly different things than your workloads. And we'll see why in the demo. It's not a big deal. It's just you get some silly looking strings in there. All right, so off we go. Let's see if everything is going to work. All right. So I am using K3D clusters under the hood here. I am using 3 K3D clusters, all of which share a single flat network and have different CIDRs and different cluster domains and do all of the things that we said. And it turns out that setting that up is really, really hard. So I have done that all ahead of time. And we're picking up from the point of view where we have the application installed, we've got Linkerd installed, we've got everything linked together, and I'm going to show you what the results are. There are 2 scripts in here, create clusters and setup demo. And if you pull down the source code for this, I would strongly encourage you to go ahead and look at those scripts and figure out what's going on. Just recognize that some of create clusters in particular is just serious K3D wizardry. So,
and where are the scripts? Where is this stuff? It's up on GitHub, right?
It's up on GitHub. There's a link at the end of the demo, but this is all in github.com/buoyantio/service mesh academy. And there's a directory in there called Sneak Peek 214. All right. So at this point, we do, in fact, have a happily running faces demo where you're getting a bunch of grinning faces on green backgrounds. This is all running live, talking to my 3 clusters running on my laptop. And you can also see that although we are getting smileys and green backgrounds, we also see some of the faces fading out because things are taking too long. So let's come back over here. This looks like a typical faces demo, but it is actually not. We have 3 clusters. We have a cluster called face, a cluster called smiley, a cluster called color. All of them are carefully set up so that they have contexts in my kube config with the same name as the cluster, because I believe that is correct. Thank you, William. As you will see, we are going to be typing the names of these contexts a lot through this. So I can use the face context to talk to the face cluster. If you look carefully, you'll see that those are all showing up with API servers on different ports and things like that. So I can talk to all 3 of these things. I have all 3 of them running. I have also linked these things together using the Linkerd multi-cluster extension. So if I look in the face cluster and I ask it about gateways, you'll recall William saying that. So first off, you get to watch me going, why is this taking so long? This shouldn't be taking so long. But you will recall William saying that we still do have gateways in the flat network world. The demo gods are not being kind to me, William. I don't know. But there we go. Okay.
There you go. Just had to pedal.
I don't know why it came. I don't know why it took that long. I'm just going to pretend that did not happen. The important thing is that we did eventually get to see that we have a gateway to color that is alive, and we have a gateway to smiley that is also alive. Being alive is good. That is very important. So, in this flat network pod to pod thing where we're talking about doing this communication without gateways, the important thing to recognize is that it's pod to pod without gateways on the data plane. But the gateways are still very important for service discovery, which is why you see them here. If you should run this and find that your gateways do not show up as alive, service discovery will not work, and you will be very unhappy, and all of that. So, something to pay attention to. If we check the other clusters, the smiley and color stuff, then we won't see any gateways. I am actually running the release candidate, Edge 23.8.3, and this is going to take 30 seconds to time out hunting for gateways in this Edge release. Everybody cross your fingers. We may be able to get a fix for that in before the actual release goes. Because this really should
just... Can I try something while we wait, Flynn? Can I try putting the architecture diagram up as like another window here? I don't really know what's going to happen.
It does the right thing. Isn't that awesome?
I want your thing to be the main screen. And this to be like a little comment out on the side. I don't know if that's doable.
There is a way to do that. There we go.
Okay. Well, is that too small to see, or is that okay for people?
We can try. We have a lot of things we can try here.
Oh, actually. Wow. Okay.
Interesting. How about if I do? There we go. That'll work, at least for the moment.
Wow.
Okay, and that did, in fact, come back. So I'm going to switch back to... That's not the view I wanted. Can you tell that we are experts in Restream, our streaming platform? There we go. All right. Okay, so just because there's stuff that I do want people to be able to read for the moment. What we're illustrating here is the fact that multi-cluster links are actually unidirectional. You do not have to have a fully connected graph, and in the faces demo, there's actually no reason to. The face workload, right after I switch back, I'm going to switch it again. The faces workload has to be able to find the smiley workload and the color workload, but color doesn't have to find anything else. Smiley doesn't have to find anything else. So there's really no particular reason to have links from the smiley cluster into the color cluster. You could do it. It's not going to break anything. It just also isn't going to really help anything. So I didn't bother in this particular case. Now, the linking actually happens in the setup demo script. And I want to explicitly call this out because the first time you look at a link command, it looks extremely bizarre. Pay careful attention to the contexts that are being specified there. We're running the Linkerd multi-cluster link command in the context of the smiley cluster. And we're running kubectl in the context of the face cluster. And the reason for this is when you run Linkerd multi-cluster link, that actually generates a link resource that has a bunch of information about the cluster it's running in so that other clusters can talk to the cluster you ran link in. Then when you run kubectl apply, you do that in the context of the cluster that you want to be able to reach out and talk to the first cluster. So in this case, we're running multi-cluster link in the smiley cluster to get a bunch of information about how to connect to the smiley cluster. And then we pass that into the face cluster so that face knows how to talk to the smiley cluster. Did that make sense, William, or did you think that was just completely bogus?
Made 1,000% sense to me, but
okay. Well, if anybody
architecture diagram for past 7 minutes, so
yeah. So if anybody out in the workshop channel,
anymore.
If anybody out in the workshop channel or out there on other chats has questions about that, then yeah, drop them in the workshop channel and we'll come back to that. Okay. Once again, we could do links the opposite direction, like from smiley back to face or smiley over to color, but we don't need to, so I didn't bother. Okay. You remember I said that the Linkerd multi-cluster link command creates a link resource. We can actually look at the link resource if we want to. So we can see that the face cluster has link resources named smiley and color. And we can look into one and see a bunch of information like, there's a secret out there that has cool stuff about credentials. And there's an IP address for the gateway itself. That happens to be a node IP address in this thing. And there's some stuff about identity and all this other cool stuff. So that is there if you want to look at it for some reason. It also does give you a kind of handy way to much more quickly get answers about, are there links in this cluster? You can just look for link resources. Okay. So remember, the demo is running right now. So let's go and take a look at what's actually running in the face cluster. And by running in this particular case, I mean, you can see it's still functioning. It's still getting grinning faces on green backgrounds. If we look into this thing, in the faces namespace, in the face cluster, we see a face workload and a color workload, but no smiley workload whatsoever, despite the fact that the demo is able to fetch smiley faces. So what services do we have here? The services are a little bit weird. We have our usual face service, and we have the color service, but then we have these two wacko smiley and smiley services. So the smiley service is the one that's getting mirrored out of the smiley cluster. This is where I must apologize and must point out that this is why it's a good idea to give services and clusters different names. The first smiley is the name of a service in the second smiley, which is the name of the cluster. That's what's going on there.
You should have used Hungarian notation for this. You could have gotten smiley s dash smiley.
Exactly. Yeah, that would have been great, right? So if we switch over and we look at what's running in the smiley cluster itself, in its faces namespace, we see the typical faces smiley and smiley 2 workloads and their corresponding services. The magic that's going on is in a label that's on the smiley service in the smiley cluster. I'm really going to have to come up with different names for this stuff. But if you look over here, you will see this mirror.linkerd.io/exported:"remote discovery. If you are familiar with this from 2.13, you might be familiar with seeing a value of enabled on that label. But remote discovery is the cool one that makes the flat networking stuff work. As soon as you put that label on, then the cluster on the other side of the link, the two control planes will talk to each other and arrange for the mirror service to be created. Also, as William pointed out, if you do say enabled, it'll still work. You'll just be doing exactly what happened in 2.13, where you go through the gateway. That's totally supported. Like we said, that'll be supported for quite some time. All right. Yeah, and again, it's the mirrored service shows up as service name dash cluster name, and that's why we see smiley dash smiley here. Okay, another instructive thing we can do is look at the endpoints of all these services. If we look at the endpoints of the smiley service in the smiley cluster, we see, hey, look, there are two endpoints, which makes sense because there are two replicas of the smiley workload in the smiley cluster. If we look at the endpoints of the smiley service, the mirrored service, in the face cluster, we get nothing, which on the face of it is a little surreal. What's happening here is that the Linkerd control plane is keeping track of all the endpoints for that particular service, and it is not bothering updating Kubernetes API server with this information. William, you might be able to shed some light. Is that just because we all like to be lazy, or is that to try to minimize some of those feedback loops that you were talking about? I believe it's the latter.
I actually have no idea. Yeah, that's a great question.
I'll have to go ask.
For optimization
purposes. Yeah, clearly. I'll go ask one of the engineers about it. It'll be fun to see what they answer. Fortunately, there is a Linkerd diagnostics command that you can use to ask, hey, what are the endpoints of a specific service? And we're going to run that here in the face cluster to get the endpoints of our smiley service, it's important that you use the fully qualified name, which you might be used to seeing, blah.service.cluster.local. But I actually changed the cluster domain here to face because, like we said earlier, probably a good idea if you're trying to do this with multi-cluster stuff in the flat world, because now identities get preserved all the way across. And if we do it this way, we can tell where that identity came from, because the identity will also have a name that looks like that. I have also been told that I lied to you a minute ago. So let me finish talking about endpoints and then I will correct my lie. So if we run Linkerd diagnostics endpoints, we see that there are 2 endpoints for that service, which is great. And even more importantly, we can see that the IP addresses of those 2 things are the same IP addresses that we see up here. So this is kind of interesting in that we are very much trusting that multi-cluster works by having pods able to speak directly to other pods here, and that's why you get to see the same IP addresses. Now, I've been told by Alejandro, who is one of the maintainers of Linkerd, that I lied when I said that you need to have the gateways for service discovery to work. It turns out that you actually don't need to have the gateways at all. But apparently we have to go through and do a little bit more work to properly qualify turning off all of the gateways and installing it and make sure that everything still works. So please forgive me for such horrible lies, everyone. All right, moving on. Burying my lies in the past or something. Okay, so the end result here is we have a Smiley workload in the Smiley cluster. We have a Smiley service that is properly mirroring and getting endpoints out of the Smiley cluster. But I would like to point out to everyone that the faces demo, the face workload talks to, if we bring up that again, the face workload talks to the Smiley service. It does not talk to the Smiley service. But again, we have a working demo here. So how is this working at all? The answer has to do with, you might have noticed that the face cluster also had a service named Smiley. And if we take a look at that service, quick, William, what looks interesting and weird about this service?
All the different colors that it uses, red and yellow and purple.
What looks weird about the content of this service? This is a quiz. We're going to find out how much William really knows about Kubernetes.
The content of the service?
Yeah, in the spec.
No idea.
It actually has no selector. So this service can never match. It can never match any pods. It can never have any endpoints. And its only purpose in life is so we can attach an HTTP route to it. In this particular case, we have already attached this one, which says, take all the traffic going to the service named Smiley, going to its port 80, send all of it to the Smiley service. And that is, in fact, how the demo is working. The demo, the face workload, tries to talk to Smiley, lands on this HTTP route. The HTTP route redirects it all to Smiley, which tosses it back across to the other cluster. And the end result is that you get completely transparent communication across pods, across clusters, and you didn't have to change anything in the application at all. There are ways that we could do some other really cool stuff here, and some of that we're going to show, and some of that we don't really have time for. But this is also an area where there's, keep an eye out on future development here, because there's some other stuff that we kind of have in mind to make this more graceful still. All right, inconvenient truths. If you looked back, you may have noticed that we were in fact using a policy.linkerd.io HTTP route, specifically a policy.linkerd.io/v1 beta 3 HTTP route. That's because we put a timeout in there. And you must be using that specific version. You can't use policy.linkerd.io/v1 beta 2. It doesn't have it in there. You can't use gateway.networking.k8s.io yet. We talked about that earlier, but I wanted to call it out again. Okay, another one that might come up. You cannot use an HTTP route in the face cluster to toss traffic over to the Smiley cluster and then have another HTTP route in the Smiley cluster do something different with the traffic. And the reason for that is actually exactly the same as the reason why you can't stack HTTP routes up in the same cluster. What happened there was you could see that when we went to look up the endpoints, we got endpoints that were directly in the other cluster. So Linkerd will see the traffic going to the HTTP route. It will choose an endpoint and go straight to the endpoint without giving anything else a chance to do any further routing. Did you just unmute because you were going to heckle something, William? Or
No, I was wondering whether that was something different about pod to pod, or was that also true when you had a gateway in there? Because the gateway would then have another opportunity to interpret the
oh,
HTTP route, on the destination cluster.
I believe that it's different with pod to pod, but I actually need to go test that. I'm not going to lie again.
Yeah, I suspect that's right. I suspect this is
Yeah.
going to be one of the differences because, as you say, the proxy is talking directly to the destination endpoint, so there's one
Yep.
opportunity to do an HTTP route,
Yeah.
interpretation.
And again, it is consistent with HTTP routes in the same cluster. You hit an HTTP route and there's one routing decision made. That's it.
Right. There's an interesting thread, which I'll repeat again for posterity, if people are listening to the recording and not live on the Slack. But Dan is asking, these pseudo endpoints, where do they live? Are they living in the control plane? Are they living in the data plane? Not having the kube endpoints feels like might cause confusion, or like if the control plane goes down, then like suddenly that cross cluster communication doesn't work. And Alejandro says, well, the proxy. So yes, the control plane is what is kind of the authoritative source, but the proxy is also caching all of those. So if you have a network partition and you can't talk to the control plane anymore, then like that communication will still happen.
Yeah.
With the caveat that you don't get updates until the control plane is back alive again. I do think it's an interesting question, which I don't know the answer to, which is why don't we have the kube endpoints? Which I think is the question you brought up earlier.
Yeah, and we'll go and find that out, I think. There's also the caveat that if I recall correctly, if you don't have traffic to a given service for a while, then eventually the cache gets flushed. So if you have a service that's not doing much and you have that sort of an outage, then that might also be interesting. So I guess the moral of that story is make all your services busy.
I think the moral is, run a highly available control plane, which Linkerd provides
we do
for doing that.
Yeah. Okay, so I'm going to show a timeout in here. From previous runs of the Faces demo, we tended to find that a 300 millisecond timeout worked out pretty well for reducing some of that, some of the places where we were getting empty cells, and it still seems like it worked out pretty well there. We get many, many fewer fading cells, and we get more where you see the timeout counter going up. We shall leave it as an exercise to the reader why we get any empty cells at all. But the main purpose of doing this was to demonstrate first that, yeah, hey, look, HTTP timeouts actually do function. HTTP route timeouts do actually function. But the other one I wanted to point out here that's a little more subtle is that, remember, this is happening across clusters. And the timeout stuff that you would do for same cluster services just works, which is one of the things that we've been kind of repeatedly hammering on here, that part of the point of this flat network thing is that all of the usual things with Linkerd just behave like the usual things with Linkerd. And that's a huge win.
Bravo. Nice demo. Well said.
The other thing we can do here is, let's go back over. So I mentioned earlier that there's one thing about this architecture diagram that I didn't really update, which is that there's a color workload running in the face cluster right now. And at the moment, we're actually getting colors from the same cluster. But we do not need to do that. So what we're going to do here is show how we can just turn on mirroring for the color 2 service. That's the one that returns blue. So we're going to mirror that into the face cluster, and then we're going to show traffic splitting across clusters. We start by adding that mirror.linkerd.io exported label. And as soon as we do this, we now see that there is a color2-color service that has appeared in our face cluster. And we can check out the endpoints again. And we can see that, again, we've got the same endpoint IPs that have appeared across the cluster boundary. So we should be able to talk just fine to cluster 2 right now. And the way we will demonstrate that is we're going to apply this HTTP route, which takes 50% of the traffic going to the color service and hands it to the color service. And it takes the other 50% and hands it to color2-color. So if we do this, once we apply it, what should happen is that half of our cells will get a blue background and half of our cells will get a green background. All right. And if we give a little bit of time,
it's going to work.
But it did. See?
Oh, amazing.
That's not actually, I mean, okay, that is pretty cool, right? You can do canaries across clusters. But what gets to be really kind of cool about this one is that if we come back over here, we can edit that route. And if I come over here and I literally delete this backend ref entirely and flip back to the browser, then suddenly I'm getting all blue backgrounds. On the one hand, that seems like, oh yeah, dude, you just fully migrated a canary. No, what I actually did was I migrated a workload across a cluster boundary, because I can come back over here and I can delete the color deployment from the face cluster entirely. I could repeat that until it's gone. But if I come back over and I look at my browser again, everything is just fine. So one of the really cool things that happens with some of this stuff where we get to do this more complex routing across cluster boundaries is that you end up able to migrate between clusters by deleting things, which is a pretty cool place to be in a lot of ways. And that is the end of the demo so far. There is, let me bring up this banner again. That's a direct link to this particular directory in the GitHub repo, or you can go to github.com/io service mesh academy and just look in the sneak peek 214 directory.
And that includes your scripts for setting up all the flat networking across K3D and all that stuff?
That includes everything I've shown to so far today. Let's see. The endpoints, this is a question from YouTube. The endpoints behind the mirrored service are the destination pod IPs rather than gateway IPs. That is exactly correct. This is also why it is necessary to have this set up so that you can have a pod speak directly to another pod using its IP address. One thing that we did not, well, we see if there are any other questions coming in. A thing that's not really in the demo, but that came up a little bit in the slides was the certificate setup. And you're going to be able to tell that I'm doing this live instead of like with the Slick demo, because I'm probably going to make many more mistakes. I have here an issuer for smiley and an issuer for face and an issuer for color. And if we look at the trust anchor, a couple of things. One is the trust anchor is still named root.linkerd.cluster.local. The trust anchor is always named root.linkerd.cluster.local. And its subject key starts with Delta Echo Delta 4 Foxtrot 1. All right. If I then repeat that and look at one of the issuer certs, then first you'll notice that its name is now identity.linkerd.face because of the cluster domain change. And you can see that it is signed by our trust anchor. I can look over all of these, and the scripting to generate these is also in that repo. But all of these are the same thing, where they have identity.linkerd.cluster domain, and they're all signed by the same trust anchor. If they were not all signed by the same trust anchor, MTLS would not be working across these cluster boundaries and bad things would happen. But I wanted to point out here both that there's a signing relationship where the trust anchor is signing all three of these issuers, but each cluster has a unique issuer. I also wanted to point out that the name in the issuer cert changes with your cluster domain. All right.
And bad things would happen is basically communication won't work. Like Linkerd will deny those connections because it doesn't trust you.
Yeah.
The cluster won't burn down. You just won't be able to talk. Linkerd won't.
Yeah. Bad things in the functional sense, I guess.
Right.
I'm not getting any other questions so far, which is kind of making me a little bit nervous because it means that either we explained everything perfectly or nobody understood what we were saying. I guess I'll go with we explained everything perfectly.
That's what I'm going with too. Where the soothing sounds of our voices gently lulled everyone to slumber.
That's okay. I guess that is a third option. Everybody fell asleep. If it were just me on this and you weren't around, I'd be worried that my network connection had just broken half an hour ago and nobody saw it.
And no one told you.
Yeah.
I think we're
asks,
good.
Jason's such a troublemaker. Jason just asked, why use separate names for each issuer certificate? So that they match the cluster domain that you have assigned to your clusters, and each of my three clusters has a different cluster domain. We didn't really have time in this one to show off cross-cluster authorization policy, which relies on unique cross-cluster identification. But yeah, that's kind of landing in that bucket. And we will, I don't know exactly when we're going to do it, but we will definitely be doing a deep dive later that shows that off as well. I don't know if that's probably not the next Service Mesh Academy, but we can go and I don't know. We'll figure out some place and we'll do a fancy demo and it'll be a lot of fun. All right. Well, in that case, somebody is typing. Maybe there's another question. While we're waiting to see, let me come back over here. Oh, can we show how this looks in Buoyant Cloud?
It's a great.
I hate to say it. It is a great question. I hate to say it, but I don't have Buoyant Cloud set up with these clusters. Oh man.
That would have been an awesome demo because you could actually see the services.
Yeah. I feel like such a fraud now.
Okay, Amir, you're hired. Demo officer.
Yeah. So the serious bit there is we can definitely show this in Buoyant Cloud. Ping. Jason is volunteering. Jason, yeah, hit me up as well, and let's try to set that up for a time when we can all make it, because it'll be fun for me to show up and heckle. I know, support Jason. Yeah, that's what I want to do. And yeah, in Buoyant Cloud, you're going to be able to see all this stuff, and it will be pretty cool.
Yeah, it'll be a nice visualization.
Yeah. You'll also note that I did not show Linkerd viz with any of this, also for time reasons. It's slightly less cool in Linkerd viz because there are multiple clusters involved, and so you've got multiple dashboards involved, but that makes Buoyant Cloud that much cooler with this. Yep. Not sure how happy GKE's gateway controller will be with all the resources being in the official gateway API group. It shouldn't be a big problem. Um, yeah, I would not expect that to be a big problem. Just thinking about some of the conversations I've had with the GKE Gateway API people, um, we're not. The thing that's in the official Gateway API group is the HTTP route. Actually, I guess there are two things here. Okay, question one or item one is it's really only HTTP routes that appear as resources on the cluster. So you're not scaling a lot of stuff that's really disastrous. We do not use, Linkerd does not use the gateway resource for anything at all. So we don't use it for anything, and we don't attach services to gateways because we are a service mesh. And the way the Gamma working group has currently specified service meshes to use HTTP routes is that you attach them to services, not to gateways, because there's really no, meshes are kind of not about crossing administrative boundaries in a lot of ways, where gateways are all about that. You've got a gateway where you can cross the boundary from the big scary internet into your nice warm safe cluster, for example, whereas everything that the mesh is doing is within its security domain. So gateways don't really make a lot of sense for meshes right now. So there shouldn't be a big scale issue. There is one interesting issue where if you have the policy.linkerd.io CRDs installed, and you also have the gateway.networking.k8s.io resources installed. If you then do kubectl get HTTP route, you will get the Linkerd version, at least in many of the cases we have seen.
We win.
Which, I mean, on the one hand is great because we win, and on the other hand, if you're trying to use the official one, it means that you have to do annoying things like kubectl get http route.gateway.networking.k8s.io -in faces or something like that. So we're kind of trying to figure out a reasonable solution to that. And unfortunately, a reasonable solution to that seems to involve editing kubectl itself, which makes me very, very unhappy.
I think a reasonable solution is you write some CLI aliases and
yeah, I mean
tackle it
that's
that
a
way.
reasonable short-term solution. A reasonable long-term solution would be, and Dan, you did hear gateways mentioned at the start of the demo. Those are the Linkerd multi-cluster gateways, not gateway API gateways, demonstrating yet again the manner in which kubectl nomenclature means we cannot have nice things. Yeah.
It's smiley, smiley, gateway, gateway.
Exactly. All right. Well, I think maybe another 60 seconds or so to see if anybody has any last minute things, and then we'll finish up. Many thanks to Alejandro for sitting in the workshop channel and answering questions and calling me out for saying things that were wrong. Yeah.
But that were plausible.
Well, I mean, yeah. It always makes me feel bad. All right. I think we can be done then. Thanks everybody for tuning in. Join us on September 14th for talking about Linkerd and external CAs and Vault and things like that. Yeah. Should be a good time.
Awesome. Well, great job with the demo, Flynn. Thanks everyone.
Much.
We'll catch you next time.
Explaining all the 2.14 stuff.